Okay, so I'm going to collect the homework. So, dang, bro. Okay, so yesterday we finished up talking about what you need to have a Euler circuit versus what you need to have a Euler path. What was my criteria to have a circuit?
Go back to the same.
They had to go back to the same. How did we identify whether it was a circuit?
All even numbers.
All even degrees.
Oh, yeah.
So each one of your dots has to have an even degree. What did we need for a path?
2 odd.
2 odd, exactly 2 odd. Okay, so we're going to look at these two graphs and we're going to identify whether it is a circuit or a path. So the first thing you do is label your degrees. How many degrees is this top left? 2. Middle?
3.
4.
Count.
Okay, be careful. 2. Come back down here.
4.
4.
4.
4.
4.
4.
2.
2.
4.
4. 2. Okay. So this is a circuit. Okay. Take a look at your second graph. We're going to go straight across the top.
3.
3.
4.
4.
2.
2.
4.
4. Good.
4 on the other side.
4 on the other side.
3.
2 and 3. So this one is a path. Okay. So what we're going to do now is called Fleury's algorithm. Okay. The only thing you need to do with this, which is just an extension of this, is we need to now trace your edges, okay, to show the path or the circuit. So when you have a circuit, you can start at any point you want, okay, unless they tell you otherwise. So let's start here. Okay, our goal is to trace every edge and make it back to that spot. So we've got 2 options when we leave this. I can go to the right or I can go down. Which way would you like to go?
Down.
Right.
Okay,
Down.
Okay, lots of downs. So I've moved down. I'm now here. Down again. So that's your second edge. And you number. You can't go down anymore. You have to go over. So there's 3. Now where? You want to take this diagonal up, okay? So now I'm here. I can only go across because we've already touched the rest of these lines. So here's 5. Go down, there's 6. You have to go across, there's 7. You have to go up, there's 8.
To the left.
Yes, left.
To the left, there's 9.
Up.
9, that's 10.
Down.
Diagonal, 11.
Up.
12.
Left.
13.
Left.
14.
Hey.
Okay?
Down.
That's it. That's all you're doing for Fleury's algorithm. First, you have to identify, is it a circuit or a path? And then you need to go ahead and number all of your edges and make sure you make it back to the beginning.
How do you know the circuit? Like
All of your degrees are even. All of those numbers in red that we put up there, they're all even numbers.
I didn't want to do this. I want to clear it up.
When you have a path, okay, you must start at one odd vertice and end at the other. Doesn't matter which. So I'm going to start here, and we want to finish here then. So if I start in the top left, which direction do you want to head first?
Right.
To the right. There's 1, so now I'm here.
Go left.
Go down to the left.
No, I didn't say
That's
that.
not going.
Go right.
Gotta go
Down to
right.
the
It
right.
doesn't
Go
matter.
right.
It doesn't matter.
But go right.
It don't matter.
But I want you to go right.
Oh, I don't. 'Cause
Okay.
you do like-
Here's 2. So then we have to go down the diagonal. There's 3.
Go up.
Go up. There's 4. There's 5.
To the right. See, Andy, you went the wrong way, bro.
You want to go to the right?
Yeah.
There's 6.
Down.
There's 7. We have
Left.
to keep going. We have to touch every line. So
Left.
straight to the left
Yeah.
or diagonal left.
Left. Straight to the left.
Okay, there's 8.
Up.
There's 9.
Down.
There's 10. And 11 will finish us back at the end. Okay. They never said that you could not touch the same dot more than once. The only thing is you cannot cross a line more than once. So Euler's theorems, which was when we decided we had to count the degrees, what that does for you is it identifies the existence of it identifies the existence of a Euler circuit or path. What it does not do, which is what you just had to do, was it does not actually find a specific circuit or path. Okay, so when you count your degrees, that will tell you whether you have a circuit or a path, but it will not find it for you. You need to find it yourself. Questions? Okay, so down at the bottom of the page is just the directions on everything we just did. Okay, your first thing you have to do is determine, do you have a circuit, a path, or neither? Okay, then you need to decide where you need to start, and then you need to number your lines until you create your path or circuit. Okay, so that's just notes on what you need to do. We have 11 graphs that we're going to do. I'm going to do the first 4 with you, and I'm going to let you try the other ones on your own, and then you can come up and put the answers up, and then we will cover the last section, and we will be done.
Let me do that.
Okay. So, graph number 1. First thing we have to do is come up with the degrees of each one. So, A has a degree of
2,
B, 4,
2,
2,
3, 4,
4,
yeah, 4,
4,
2,
2, 2. So we have a circuit. We have a Euler circuit. Okay. Now, it tells you in the directions, in a Euler circuit, pick vertex A as your start. So we're going to start here. What direction would you like to go first?
Down.
Down to D. When we leave D, where are we going?
Down.
To F.
Over.
We have to go to the right to G.
Up.
Up to E. Up to C. Left to B. Down to the right. 8, 9,
Yeah.
and 10.
They like that, you heard me?
Now, does Notorious need to match this?
No.
No. She could have started off going to the right. There's many different ways to do this, okay? So, if you take off on your own and you don't have what we have up here, that is okay. Okay? Graph number 2. A has a degree of
2.
2. We're going to jump down to G.
2.
2. D.
3.
E.
4.
Let's go down to H.
2.
F.
2.
2. B.
2.
C.
1.
1. Okay, so we have a what?
Yeah.
Path. So when I have a path, where do I need to start?
Hey,
Any of the odd. So I can either start at
C or D.
C or D. Okay, it does not matter. Which would you like?
C.
You want to start at C, which means we're going to end at D then. Okay, so the first thing we have to do, we've got to go across to B. There's nowhere else to go. Once we're at B, we have to go down to E. Now we've got some choices.
Go down.
You want to go to F.
No, go down.
Okay, so there's 3. One, we're at F, so we have to go to H. And we're in H, we have to go back up to E.
Left.
Now we have to go to the left. That takes us 6.
Down left.
You want to go 7. Up to A, that's 8.
And back down.
And down to D, that is 9.
That's simple.
Question.
And I gotta get it right.
Not too bad, right?
All right.
This section doesn't get any harder. This is it.
Stop lying to me.
Yeah.
That's what
Okay.
they all say.
A has a degree of,
4.
B has,
4.
B,
Oh, my bad.
2, C,
4,
4, D,
4,
E,
2,
and F.
2, circuit.
Circuit. Okay, so directions tell me I need to start at A. What point am I going to?
I'm going to B.
Then to B. Okay,
Then to D.
if I'm at B, I have to go to D. Now I've got options. Where you want to go?
F.
You want to go to F. So there's line 3. Leaving F, we've got to go to C. So there's 4. Now we've got options again at C. Back to D. Okay. We're at D. My only other option is to go up to A. So there's 6. Now I'm at A. I've got an option.
Go to C.
Go to C. So there's 7. C has to go to E then. And E goes back up to A. Do one more with me, and then you're going to finish the rest on your own, and we'll put the answers up. Okay. A has a degree of 4. B, 4. C,
4.
D, 6. G, 4, and F. What is it? Circuit. Circuit. So that tells me we need to start at A. What point do you want to go to? You want to go to C. There's 1. We're at C. Where are we going? F. There's 2. We're now at F. Where are we going? C. There's 3. We're now at C. My only other option is to go across to D. So now I'm at D. You said F. Okay. There's 5. Now I'm at F. The only other option I have is to go to G. I'm now at G. I'm going to go to B. So there's 7. We're now at B. Back to G. Okay, there's 8. So my only other option is to go to D now. There's 9. Now what? At B. So there's 10. If we're at B, my only option is to go to A. There's 11. And then I've got to go to D and back to A. Take a couple minutes and do graphs 5, 6, 7, 8, 9, 10, and 11. If you end up with a graph with neither, that means you can't do anything. So once you write neither, you're done. There is only one.
A path can only have 2 odd numbers, no
Yes.
more.
No more, no less.
Can I get the homework from you?
It's over in the bin.
Where?
Alexis. In the last slot, the 4th block.
I've never tried another routine.
Miss Smith,
Yes.
do we have to go on the outside view?
Huh?
We have to go on the outside view?
Yes. Those are lines part of your graph.
Sorry.
You can't go like that across the same line.
You know you cannot cross the same line twice. If somebody has 5, they can go up and do 5. You don't have to write all the degrees up there if you just want to write if it's a circuit or a path and then number your edges. That's fine. So obviously we can tell if you picked a circuit that they're all even. Or if it's a path, there's 2 odd. Marcus, can you just write at the top whether that was a path or a circuit? Good. Number 5 should have been a path. You had an odd vertex at E and an odd vertex at H. So notice he started at E and he finished at H. Anytime you have a path, you should always start at one odd and finish at the second odd. Any questions on number 5? Does anybody have number 6 yet and would like to put that up?
I mean, I know the answer, but I think about it. I'm confused on how to like number it.
Why? Whatever line you cross is how you number.
Yeah, I know, but like,
And your line goes from dot to dot. So what? Because it all crisscrosses?
yeah.
Okay.
This was
Actually,
really,
yeah,
this
you-
is really hard.
Let me do this one.
Was
So
this
I can
one?
catch Trey.
You want to do this one?
Yeah, let me do this one. All right. Thank you, sir. Okay. This is a path. You've got an odd vertex at C and an odd vertex at D. Okay. So you need to start at one of these. Okay. So where do you want to go?
I don't see.
You want to start at C. Okay, so you've got 3 options. You can leave C and go to A, you can leave C and go to E, or C and go to D. This is not a stopping point because there's no dot there. You have to go from dot to dot. So which way would you like to go?
Let's go.
Let's go up. Okay, 1. So now, actually, let me switch colors. It's easier. So now, you're at A. You can either go clear down to F, around the outside to E, or across to B. So if you take this edge on the outside, you go clear down to E. This is not a stopping point either. There's no dot there.
All right, let's see.
Okay? So this entire edge is 2, the whole way down. Okay? So this was edge 1. This is edge 2. Okay? Now where would you like to go?
Let's go to B.
Let's go up to B. Okay, so you're going across this entire line. There's 3. We're now up here.
Then F.
Okay, you can take this thing the whole way down to F.
Up to A.
You want to go up to A. So that's 5.
Over to B.
Over to B, there's 6. You've got to go down to D, so there's 7. Okay, because B can't go anywhere else. We've already gone here and here. So now we're here. We only have 4 more lines to touch. We've got this one, this one, this one, and the one across the center.
All right, let's do that. In the square.
That's fine. We can go down in the square. 8, 9, 10, and 11.
Is there ever gonna be like a time where it's not gonna work? You go the wrong way.
Right.
Cause I don't know if I'm doing it. I'm just,
Just right
I don't
now.
even know what I'm doing. I got completely lost.
Finding a path.
Yeah, but every time I'm trying to do it, like
Like you
get
get stuck.
somewhere. Yeah, I can't, and I erase and start over, and I get stuck in
You have to make sure you're going from one odd number to another, right?
here.
Yeah, when it's a path, you have to go from one odd to the other odd. Did you start at an odd and end?
Mhm. Like this one, I quit that one to go up here, and I was doing the same thing. You can see what
It's hard if you really think.
Guys, work on 7, 8, 9, 10, and 11 while I work on this one.
Just write down the numbers on the edges real quickly and not even think about it too much. Because then you'll be like, oh wait, is this the right one? This one that I just write? You know what I mean?
Number 9, the one you can't do.
You figure that out. We're gonna start A and my suggestion when you do this, try to stick in one area and get all the lines and move on to the next area. Don't do like bam and then try and get it center. Like, when you leave A, go to E, try to do like this little area first. Try to
Go down to E, I need to try to get.
Right. You need to go, you need to try to get back to A.
I did play it.
That's why we're trying to get this middle area.
If I go to McDonald's today, you can hook me up.
Now, don't forget this corner, so you get this corner.
I thought she was gonna say no. I really thought she was gonna say no. I mean, even going.
Interesting what you heard. What do you look at?
See how like I did it in like segments? That way you're not losing any of the spots. That's the easiest way I found to do it. Go back to this one. Starting on.
Number 9, the one you can't do.
Yeah, dude.
And I think out here.
Yo, that's straight. We're not quit on it.
It is impossible.
Right, the number 7.
Yeah, you put none. This movie impossible. It doesn't matter. None either possible.
What's none?
Yes, like you can go to the dock multiple times. You just can't
What's
cross
the
any
green
line.
one?
Any line that you already have.
What is neither? Neither none the same one?
Yeah, I just write them.
Don't say both.
I said, whatever.
Hey, did y'all already do that?
Yeah.
Yeah.
Hey, bro, I got it wrong.
That's what I.
Wasn't paying attention.
Damn.
So don't go too far.
Ian got it though.
How the fuck you at?
I just wasn't paying attention.
I wasn't gonna take the test.
She said move.
Right, well, I ain't never moved on the test. Leave me alone.
Actually, what you might
Just
want to
have
do
to switch sheets with the-
back up to 5.
So much good.
Spanish on.
Try to finish out this area. And then come across, because you want to end over here. So try to do like this area and then.
No, it's not right.
So hold on,
I haven't stopped.
this is 6.
Easy right here. I knew she was going to say something to me today, bro.
Number 9 is you.
Nah, it's both.
Yeah.
Both, bro.
You must did that right there.
What about this, bro?
Because we're having issues again. Okay, does anybody have graph 7 that they can put up?
Yeah, I got it.
I got. Yeah, I had all of them. I can do number 9. Call number 9.
Hey, I got. Damn, we got 9.
See the little.
Damn.
Oh, sorry. Okay, so do it this way. Go across to 6 and up to 7, like you were. Don't leave those on. Go across to 6, up to 7. Instead of coming this way though, go back this way.
Addington.
And then you can do this way.
Got it, right?
I think you messed up.
No.
So this year, right?
And either go up, around, or the same round. cover this whole entire area to the left and to the right. So I would move down here. Now you're at C. Your only option now is to go straight across C. I'm gonna go either up and across because of this section or down and across because of this section. All right, good. This one was a circuit, and holy cow, a lot of edges. Does anybody have graph 8 done?
About you.
I got all of them
Marcus, you want to put 8?
We'll put all of them.
I gotta take it down. What she said? One day. What?
Oh, it's way off now. How do you do this, John?
2 middle buttons.
2 middle buttons, put your fingers on them, hold them in, then release. And then you're gonna hit the middle right on each one of those.
How you doing? How you doing?
So, at this point, I will try to cover down in this section and then work my way up. I probably do it.
Right on the bottom. On number 9.
Yeah. Whatever.
What does? You got a haircut, Mike?
You know I'm doing something. Good, this one is a pat. You had an odd vertice at E and one at B. So he started at B and he finished at E. Questions? Okay. Number 9. What was number 9? This one is neither. You've got an odd here, 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 and here. So this is neither. What do we have in graph 10? We've got a path. What's my odd pieces then? C and E. Where do you want to start?
C.
C. Okay. Where am I traveling to when I leave C? You want to go to A. Okay. So there's 1. I'm now at A. Where are we going? You tell me.
D.
D. There's 2. Now we're at D. Where are we going?
B.
Yeah, no,
B.
put an F.
Hold on, we fine. B.
A.
Okay. You want to go across to A, and then of course we've got to go back to B. B can only drop down then to E. Okay. So now we're at E. Where do you want to go?
D.
You said D. 7. So now we're at D.
C.
Okay. We're going to go to C.
D.
Back to D.
C.
Back to C.
F.
We have to go to F. up to D,
Down to G.
down to G,
Over to F.
over to F,
Back to G.
back to G,
Up to E.
and up to E. Fantastic.
You heard me.
You heard?
You heard.
Okay. Your last one.
That junk is killer.
What
This
else?
junk is killer.
That's not that hard.
First, we have to determine what we have. What do I have? This is a circuit. This is a circuit. All of my degrees are even. So I need to start at A because that's what they tell me.
Go to B.
Okay. You want to go to B. There's 1.
Go to C.
You've got to go to C. There's 2.
J.
Go to J, yeah.
Okay. J.
K.
And then go to I.
K.
I go to K on the bottom one.
Doesn't really matter.
Go to K.
Okay.
I
Let's
would
go to
just,
K.
I
then.
would have gone to I, K, J, back to K, just to get all that
Then you
little
go to
area done.
J.
Okay. You want to go to back to J then, and then to I. So they kind of did the same thing. You just took the up and then
Yeah.
the bottom. Okay. So now we're at I. Where do you want to go?
K.
Okay.
Yeah.
Okay.
Up to L.
Up to L.
N.
Down to N.
M.
M.
P.
P.
O.
O.
L.
P.
P. There's 14, 15.
Go to, yeah, F.
E.
Okay.
F.
Down to F.
G.
H.
Go to H.
No.
Careful. We've got to cover this section.
Go
So
to
you
H.
can't.
Oh, yeah,
Okay.
my
So we're going to
bad.
go
Yeah.
17.
And then go to L and then go back.
Go to L and back. You don't want to miss this section here.
I.
So 20,
G.
21,
F.
22,
G.
E.
23,
E.
24,
E.
25 is back, 26,
A.
and 27.
You heard me.
That's not far off.
So, my advice, if you're struggling with numbering your edges, is try to do one little area at a time. Don't try to do like the entire edge and then go back and try to do the center. You're going to lose it.
Yeah.
Try to do little tiny sections at a time. Okay. There will be, I believe, 2 of these on your test on Tuesday. All right.
When that's
Tuesday. We're going to review Monday, test Tuesday. Okay, this is the last 2 things we have to talk about. Eulerizing graphs. Okay, so what you're basically going to do is take a graph that does not have a circuit and you're going to add extra pieces to make it a circuit. Okay, so all of your steps are here. Your first step, identify all your odd vertices. Okay, so we're going to do this as we talk about the steps. So if you look at this graph right here on the left, what vertices are odd?
For the first one,
Mm-hmm.
I don't see any.
H,
H? No, H.
H,
it's
E.
five, yeah.
H, and E. That's it. Okay, so now that you've identified the odd ones, we want to duplicate edges that are already there to make these now even. So watch what I do. I'm going to take a line from E to F. Okay, so when I add that extra edge to E, it now makes E a degree of 6.
What if you just made one from E to H?
You cannot. Okay, so Marcus just said, why can't I just do this? That would make sense. That would be easy. You cannot create any new edges. You can only duplicate what is there. There is not an edge that connects E to H. So that's a no-no.
It's making multiple edge.
You have to make a multiple edge. Okay. So watch. Hold on. I'm not done yet. So I went E to F. When I created this and put this at F, F is now odd. So you've got to double up and do another one from F to make it back to even. Well, now G is odd, but I can do another one from G to H. So G is back to even, and H is now even with 6. You want to try to do this in the least amount of edges possible. You don't want to be drawing 20 lines. Okay, you're going to drive yourself nuts. You want to try to do it in the smallest amount possible. So if you look at this middle graph, Which ones are odd?
E.
E and C.
That's it.
E and C.
So go from E to F, C to F.
I want to see it.
And I'm
C
going
to
to
F and F to E.
Okay, you cannot draw a line that goes from C to E because there is not a line that is already there. You have to create multiple edges. You cannot create new ones.
C to F.
So you can go C to F and F to E. Okay. There's already lines drawn there, so you can duplicate them. You cannot draw anything new. Because that's what Marcus said. Why can't I go from E to H? Well, you can't. There's no line that connects those two automatically. Okay? Instead of going around to F, you could have also went E to B and B to C. Okay? So there's multiple ways to do this as well. Okay. This is odd. There's 3 odds on each side of this square.
Yeah.
Okay. So watch what happens here. I'm going to go odd to odd, and that makes it even. Okay. My next one is next to an even one. So we're going to go what I call around the corner. So you're going to go from odd to even, and then from that dot on to the next odd. So when you double up on that corner, it went from 2 to 4. So you changed it, but you still kept it even. Then we can connect your next 2 odds. We can skip this corner, connect my next 2 odds. This one is also going to be an around the corner then. Okay. So odd to even.
Wait.
And then to odd.
Why would you skip that one?
This one?
Yeah.
Because you've already made this even when you connect these 2. So you don't want to mess with it again. It's already even. Does that make sense?
Yeah.
So you want to skip this and go to your next odd. Okay. So you create even here, odd to even, odd to odd. Okay. Do your around the corner again. And then you've got these 2. So my suggestion when you get big squares like this is start at a side and just follow it around. Okay, that's the easiest way to deal with this one. Okay, take a look at this one. Which ones are odd?
C.
C and D.
So can you
You can just connect them. They already have a line that connects them. We just connect them.
Oh.
This smaller square, we've got odd, 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 and odd, odd.
You can just connect them.
Okay?
Yeah.
You only have 2 on each side. Okay? So that makes this one super easy. Odd to odd, odd to odd, odd to odd, and odd to odd. Only when you have an odd number of odd vertices on the side that causes an issue. Okay, we've got odd, 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 or
That
even
one,
odd.
that one at the right above the first one you made is also odd. Yeah, that one.
This one,
That one too.
and this one,
The one below it.
and this one. Did I catch them all? I don't know who would have taken it.
You know.
Okay. All right. This one might be slightly difficult.
And pretty difficult.
Where would you like to start? You tell me.
Well,
Because we can make this work no matter where you want to start.
I started at the top left corner.
Okay.
Oh, it's right here.
You started over here?
Yeah.
Connected this one to this one?
Yeah.
Yeah, I thought you could.
You can. There's a line that connects the 2.
Okay.
Okay. So Marcus went here. Okay. That's fine.
And then the top 2.
And then you connected these top 2.
Yeah.
Okay.
That's pretty much it. So far.
Okay.
You do
You can go from that one
You can
down. Yeah.
you can do it around the corner here because you can't draw the line that connects the two, but I can do from here to here and then bounce it over.
And then you can do those bottom two, right?
Okay, these two? Or you can, okay, these two, that's fine. And then you can bounce this one as well. There's one in between, but you can bounce across.
Is that all of them?
Okay, that's it.
This is easy. Bottom James.
The hardest part is making sure you have all of your odd vertices first. Okay, all right, last piece. This is it. SemiEulerizing graphs.
Oh, God.
It's not as bad as you think. Instead of creating a circuit though, we're trying to create a path. Okay, please stop. Instead of trying to create a circuit, you're trying to create a path. So you need to identify all of your odd ones except for where they wrote start and end. They need to stay odd. So you do not do anything with those ones. So this one is odd. Start is odd, but we're going to leave it alone. This is odd and this is odd. End is odd, but we leave it alone. This is odd, and this is odd. Okay. Where would you like to start?
The one beside start.
The one beside start, what are we doing?
Bounce.
We bouncing. We can either bounce this way, or you could have bounced around the outside corner. Again, you can't draw a line that connects the two odd ones because there's not one there originally.
So
Okay.
I got a question.
Yes.
If we were just to connect the two odds on the side, would we have to bounce the top one all the way around? Or you
Yeah,
just, you
pretty
just
much.
can't do that?
Yeah. Like if we
Like
did the
we
two
went
on the
here and
side.
did those, then you worry about it. You had to bring it all the way around.
No. If you would have, so Natria's question was, if I take this and I connect these two,
And the other two.
you
The other side.
and these two on the other side, you could just bounce this down. Because you already have lines here that connect these dots. You can create your duplicate edges.
So can you do that with starting this, starting?
Why would you want to touch start and end? You want them to stay odd. You're creating paths, which is why we do not circle them. Leave them alone. When you're SemiEulerizing, you're trying to create a path, which means you need two odd vertices, your start and your end. Okay?
Oh.
So my next one. These two at the top are odd. These three along the sides are odd. And these two at the bottom are odd.
You bounce to the start and to the end.
I think we should connect the top two first, right? Those
What do you
two.
mean, can you bounce from the start to the end?
Like you see the one at the bottom by end.
This one here?
Yeah, can you bounce to the end and then no?
You want to go here?
Yeah, you do that.
Okay. You can.
Oh.
Because then that still leaves your end at an odd because you bounced it. Okay, so it leaves it odd. Okay, then what would you like to do then,
The
Alexis?
three on the side.
You want to do the three on the side? So you can only connect two odd.
Yeah.
Okay, so now to do this one,
You're gonna go around the
you're
corner.
going to bounce it.
Gotta bounce it outside.
Okay. Now what?
You're gonna have to bounce that one.
We're going to have to bounce this one all the way to my next odd. Okay, and then connect these two. Now, what you just did is not technically optimal. You've created more lines than what you needed to. You are trying to do this in the least amount of lines possible. So while this works, it's not efficient.
Wait, I have a
Yes.
part supposed to stay odd, but
Uh-huh.
I'm drawing those lines. Did it make it through?
Because it started with 3, and because we bounced, it added 2 more. So that created 5. That's why you bounce, because then it doesn't change whether it's odd or even, because it adds an extra. Okay. All right. Take a look at this last one then.
Okay, let's do it.
Which ones are odd? Let's see. This top one, this one. That's 4. That's 4. that it?
No, yeah, that's it.
Cause start and end are odd,
Yeah.
okay? So what's the fastest way I can fix this one?
Just
Put
go,
those two.
yeah, just like that.
Bounce it, okay? Bounce it across that dot.
Bounce that. No.
Okay, what I want you to do is I want you to try these 6 on your own, okay? Those of you that are leaving for the band, it is time to go.